Hi students, welcome to Maths Pay channel. In this video, I am going to discuss about circumcenter, orthocentre, centroid and what is the relation between circumcenter, orthocentre and centroid, and finally incentre, excentre. So let's start the video. Straight away, first of all I am going to discuss about what is the main definitions of a median, altitude and perpendicular bisector. So the first one is median. So in any triangle, for suppose if it is a triangle ABC, so in any triangle the line segment joining the vertex and the midpoint of the opposite side, the line segment joining the vertex, any vertex and the midpoint of the opposite side is called the median. For suppose if maybe D, then AD is called median here. So line segment joining vertex and the midpoint of the opposite side is called the median. And here one more thing is, now straight away, what is the definition of centroid? So which is usually denoted by the symbol G. Now here medians of a triangle are concurrent. So which means, so in triangle we have three medians. One is from A, another one is from B, and finally that is from C. So all the three medians of a triangle are concurrent. Meaning of concurrent is passing through the same point. So that all the three medians passing through the same point, then the point is called centroid. So medians of a triangle are concurrent, then the point of concurrency is called centroid. And one more thing is, the centroid divides median in the ratio 2:1. So AG is to GD equal to 2:1. So the centroid divides median in the ratio 2:1. Next, now move on to the second one, that is circumcentre. So here, so before going to the start with circumcentre, I would like to explain about perpendicular bisector. So what is meant by perpendicular bisector? Now, so in any triangle we have three sides. Now the line which is perpendicular to the side and passing through the midpoint of that side. So for suppose if the midpoint is D, any line which is perpendicular to the side and passing through the midpoint of the side, this is called perpendicular bisector. So any line perpendicular to the side and passing through the midpoint of the side. Now we will move on to the definition of circumcentre straight away. So what is meant by circumcentre? So we have different types of definitions for circumcentre. So we will discuss all. So first of all is the perpendicular bisectors of a sides of a triangle. The perpendicular bisectors of a sides of a triangle are concurrent, which means passing through the same points. We have three perpendicular bisectors, so all are passing through the same point. Then this point of concurrency is called circumcentre, which is usually denoted by S. So the perpendicular bisectors of the sides of a triangle are concurrent, then the point of concurrency is called circumcentre. And we will move on to the second definition of circumcenter, that is, so in any triangle, a circle passing through all the three vertices of a triangle, a circle passing through all the three vertices of a triangle. So suppose if all the three vertices are named as A, B, C, then this circle is called circumcircle, and center of the circle is called circumcenter. So which is nothing but, this one is nothing but circumcenter. So this is the another definition. So here also the same. So here one more thing is, so here SA, one more condition, that is SA equal to SB equal to SC. So that is the main condition. So the distance from circumcenter to all the vertices is same. Next, now move on to the third definition, that is very very important, so which is very useful for objective, that is in any right angle triangle. For suppose if you take any right angle triangle A, B, C, so here it is 90 degrees. So in any right angle triangle, circumcenter is the midpoint of hypotenuse. Circumcenter is the midpoint of hypotenuse. So these are the three definitions. The first one is the perpendicular bisectors of the sides of a triangle are congruent, then the point of congruency is called circumcenter. And the second one is the circle which passes through all the three vertices of a triangle, then the circle is called circumcircle and the center is called circumcenter. And coming to the right angle triangle, so in any right angle triangle, so the midpoint of hypotenuse is called the circumcenter. Right. Now next one, that is orthocenter. So before orthocenter, I would like to explain about altitude. In any triangle, so suppose if it is A, B, C, the perpendicular segment, so the perpendicular segment through any vertex to the opposite side is called the altitude. So the perpendicular segment through any vertex to the opposite side. So here the perpendicular segment passing through A and perpendicular to BC, the opposite side of A. So this is nothing but altitude, right? And here, so what about the orthocenter? So by using this, what is mean by orthocenter? So very very important one, that is, see, altitudes of a triangle are congruent. So we have three altitudes. So one is from A to BC, that is, so another one is from B to AC, that is BE, and finally, so altitudes of a triangle are congruent, then point of congruency is called orthocenter. So altitudes of a triangle are congruent, then the point of congruency is called orthocenter. Now move on to the next definition, that is in any right angle triangle, or suppose if it is A, B, C, orthocenter is at right angled vertex. So here in this right angle triangle, orthocenter is what? B. Why? Because here this vertex makes 90 degrees in this triangle. So here orthocenter is what? B, right angled vertex. So this is about orthocenter. Now what is the relation between centroid, circumcenter and orthocenter? The relation between centroid, circumcenter and orthocenter. See, the first main thing is, so centroid, circumcenter, orthocenter, so all are lies on a same line, which are collinear. collinear. This is the very important one. So centroid, circumcenter, orthocentre or collinear. And one more thing is centroid divides, or else centroid divides orthocentre, circumcenter in the ratio 2:1. Centroid divides orthocentre, circumcenter in the ratio 2:1. So which means what? G equal to 2s plus O upon 3, 2 plus 1. So by using this formula we can find, so for suppose if centroid and orthocentre is given, if you want to find circumcenter, we can use this formula. Okay, so this is the relation between among all these three. So centroid, circumcenter, orthocentre. And the next one is Incentre. See, in any triangle, if the triangle is ABC, see, these are the internal angles. So internal angle bisectors. So this one. So internal angle bisector, which means what? So this bisector divides this internal angle into two equal parts. So internal angle bisectors are concurrent, and the point of concurrency is called Incentre. So this is the one definition. So internal angle bisectors are concurrent, then the point of concurrency is called Incentre. So it is denoted by I. So here the one more definition, that is, so in a triangle, or else in any triangle ABC, the circle which touches all the three sides of a triangle, the circle which touches all the three sides of a triangle, then this circle is known as Incircle, and the center of the circle is called Incentre. The circle which touches all the three sides of a triangle internally, this is a very important thing. Circle touches all the three sides of a triangle. So internally, this is a very important one. Why? Because if it touches externally, there is another definition. So that here, if the circle touches all the three sides of a triangle internally, then this circle is called Incircle, and the center of the circle is called Incentre. Okay, now how to find the Incentre? So for suppose if A is x1 comma y1 and B is x2 comma y2 and C is x3 comma y3, for suppose, and so the distance opposite to the vertex A is known as small a, and the distance opposite to the vertex B is known as small b, and opposite to C is known as small c. Now Incentre I equals to ax1 plus bx2 plus cx3 by a plus b plus c comma ay1 plus by2 plus cy3 by a plus b plus c. So by using this formula we can easily find Incentre. And one more thing is, the Incentre divides internal angle bisector in the ratio b plus c is to a. So for suppose if it is d, then ai is to id equal to b plus c is to a. And one more thing it is, so here if it is d, then bd is to dc is equals to, which means what? D divides BC in the ratio, which is nothing but BD is to DC, that is AB is to AC. So we can easily find the ratio of BC divided by D. So which means what? BD is to DC equal to AB is to AC. This one. And then Incentre divides the internal angle bisector in the ratio B plus C is to A. So this is what? Incentre. Now, so have a look. And so we will move on to Excircles and Excentres. So here, what is meant by Incentre? First of all, the circle touches all the three sides of a triangle internally. But here, see, Excentre. First suppose in any triangle A, B and C. So we have three vertices and three sides. So three angles, triangle. So what is the definition of Excentre? Is a circle which touches all the three sides of a triangle externally. The circle which touches all the three sides of a triangle externally. So how it happened is, if I extend these two sides and so draw the circle like this. Yes, this is. So this is the circle which touches all the three sides externally. So here BC, for BC it is an external touch, and for AC it is an external, and AB also it is an external one. So the circle which touches all the three sides of a triangle externally. The circle which touches all the three sides of a triangle externally. So for Incentre it is different internally, for Excentre it is different, that is externally. So here the center of this circle, external circle, is called Excentre, so which is denoted by I1. So here what is I1 is the center opposite to the vertex A. The Excentre opposite to the vertex A is called I1. So what is I1? How to find I1 is, so by using this formula, you can remember. So minus AX1 plus BX2 plus CX3 by minus A plus B plus C comma minus AY1 plus BY2 plus CY3 by minus A plus B plus C. So by using this formula we can find Excentre 1. What is meant by Excentre 1? The Excentre opposite to the vertex A. For suppose if you want to find I2, which means what? Excentre opposite to the vertex B, that is, so have a look. So straight away I draw, so here only. So if I extend this one like this, and so here, now here the circle which touches all the three sides externally, and the Excentre opposite to B is what? Excentre to I2. So what is the formula for I2? So simple, AX1 minus BX2, so for I2, so AX1, for the first one we get minus here, and the second one we get minus in the second term. So BX2 plus CX3 by A minus B plus C comma, again AY1 minus BY2 plus CY3 by A minus B plus C. Now move on to the third Excentre, that is, so here, the place here. So here, The center opposite to the vertex C, that is I3, Excentre 3. So Excentre 3, that is opposite to the vertex C. So this one we can find easily there by using the formula same. For the first one we get the minus first, and for the second one we get the minus second term, and for the third one we get the minus at the third value, which is ax1 plus bx2 minus cx3 by a plus b minus c, like that, comma ay1 plus by2 minus cy3 by a plus b minus c. So these are all three excircles and so their excentres. From vertex opposite to the vertex A is what Excentre 1, opposite to the vertex B is what Excentre 2, and opposite to the vertex C is what Excentre 3. And this excentre divides the angle bisector. So this is also happened with angle bisector. So for internal angle bisectors for A, B and for C. So this divides the internal bisector in the ratio minus of B plus C is to A. So this is the one. So this excircle divides the bisector in the ratio, so minus of B plus C is to A. So this is all very important definitions in basic geometry, two-dimensional geometry. Thank you students, have a nice day.